For the paging demo, we're continuing where we left off in the previous demo. This time we'll add two more parameters to the get method on the expense groups controller. We'll add a page parameter and giving it the default value of 1, and we'll include a page size parameter, which will give a default of 5. We'll want to include a max page size as well to ensure we don't pass through too much data at once, no matter what the client requested. Let's say we want to limit the maximum amount of items on one page to 10. I've already added the max page size constant, so that's what we can check against. Next, we'll have to create the info we want to add to the header. To get this, we have to rearrange our code a bit so we can calculate what's necessary. This piece of code gives us all the expense groups, including the filters, and this is what we need to get the total count and total pages. The total count, well, that's a simple count on expense groups. And the total pages, well, we can get that by taking the total count and dividing it by the page size. Then we'll have to create the URIs for next and previous and the other metadata we want to add. There's a nice helper class we can use for this, the URL helper. This allows us to easily create a link from the route that's been used to access this action. We'll have to name the route though, so let's do that. So we've now given this route the name of expense groups list. And through the URL helper, we're now creating links to the previous page and the next page. Also important to know is that when we create a link, we also need to pass in all the parameters that have been passed in through query string. Why is that? Well, because these links can be used by the consumer to go to the next or previous page. And going to the next or previous page should of course also include the correct sorting order and the correct filters, because otherwise it won't match anymore. Up next is creating the pagination object itself and adding it to the header collection. We're creating a new object, that's an anonymous one, and we're going to add the current page, the page size, total count, total pages, and the previous and next links of course. Then we need to add a new header. The header collection of the response that will be sent to the consumer of the API can be accessed through http context.current.response.headers. Then I'll need to add a new header. We're going to name it xPagination. And what we'll want to include as paging header is this pagination header serialized to JSON. To serialize to JSON, we can use JSON.NET, which we already included in this project. So we now have all our paging metadata. The only thing that's left to do is add the actual paging to the iQueryable result, execute the query, and return the results after mapping. So we're taking the expense groups variable, that's this one, so it already includes the sorting and the filters. We apply paging by skipping the number of pages we don't need and taking the number of items a page contains, and we use the toList method so the query gets executed. We select each expense group and we map it to a DTO. Okay, let's give that a try. We're going to fire up Fiddler because we'll want to inspect the pagination header. And let's say I want page 2 for page size of 2. And there we go. If we look at the response headers, you can see our pagination header with all the info we added. There's one more thing we need to add though. Currently, I'm able to ask for as many expense groups as I want. So we still need to implement the maximum page size. To test this, let's set the max page size to a very small value, say 1, and let's run it again. This is the exact same request as before, we're asking for page number 2 and we're asking for 2 items per page. But as we see on screen, only 1 item is returned, as 1 is the maximum page size. It's the second item from our database that we see here, which we can gather from the ID, as results are sorted by ID by default. So this works. That's it for this demo.